Today, we doing sequences and series, starting with the quadratic number patterns. Remember the quadratic number patterns. General term is in the form of Tn equals an squared plus bn plus c. Let's say we got a number line as 2, 3, 6, 11. Let's say they ask us to determine a formula for the general term. So what's the first step we do? So first we do is t2 minus t1, which is 3 minus 2, giving us 1. Then we do is t3 minus t2, which is 6 minus 3, giving us 3. And then we do t4 minus t3, which is 11 minus 6, giving us 5. And those are our first differences, 1, 3, 5. Now we do our second differences, which is 3 minus 1, giving us 2, and 5 minus 3, giving us 2. Now we can find our general formula. To do that, we always start with 2a, which is equal to the second difference. In our case, the second difference is 2, so we have 2a equals 2. To get a by itself, we divide both sides by 2, which leaves us with a equals 1. Now we need to get b, and in order to do that, we always start with 3a plus b, which is equal to the first number of the first difference. In our case, that means 3a plus b equals 1. Now we already know a, so we substitute it in, which gives us 3 times 1 plus b equals 1. That becomes 3 plus b equals 1. Now we want b to be alone, so we take the 3 to the other side, giving us b equals 1 minus 3. Remember, when we move the 3 to the other side, it becomes negative, and in the end, b equals minus 2. Now we need to find c. To do that, we always start with a plus b plus c, which is equal to the first number of the main number line. In our case, that means a plus b plus c equals 2. We already have our values for a and b, so we substitute them in, giving us 1 plus negative 2 plus c equals 2. That simplifies to negative 1 plus c equals 2. Now we want c to be alone, so we move the negative 1 to the other side. When it moves across, it becomes positive, giving us c equals 2 plus 1, and in the end, c equals 3. And that's how we get our general term formula. So for our sequence, the general term is Tn equals 1n squared minus 2n plus 3. But in general, when there is a 1 in front of a variable, we don't need to write it. So instead of writing 1n squared, we just write n squared. That means our final general term formula is Tn equals n squared minus 2n plus 3. Now let's say we want to determine the value of the 42nd term. Here we take our formula, and wherever we see n, we replace it with the value 42. So it becomes T42 equals 42 squared minus 2 times 42 plus 3. When we calculate this, we get T42 equals 1,683. And that's how we get the value of the 42nd term. Now let's say they ask us to determine which term is equal to 1,091. Here we take our formula for the nth term, which is Tn equals n squared minus 2n plus 3. And instead of finding the term, we set the formula equal to 1,091. So we write n squared minus 2. n plus 3 equals 1,091. Next, we move everything to one side of the equation by subtracting 1,091 from both sides, giving us n squared minus 2n minus 1,088 equals 0. Now we solve this quadratic equation by factorizing. We look for two numbers that we multiply to give us minus 1,088, and the same two numbers when we add gives us minus 2, which are minus 34 and 32. So we get n minus 34. n plus 32 equals 0. This gives us n equals 34 or n equals minus 32. But since the term number cannot be negative, we ignore minus 32. Therefore, 1,091 is the 34th term of the sequence.